selected another query based on another selection criteria, and this data record is returned multiple times, you will know that it will satisfy, it actually has certain intersection property. So for those, we do not prevent, our solution does not prevent those kind of linking attack. But I'm not sure if that's what you asked, or you asked something else.
Well, it sort of answers the question, I think.
All right.
And then just another slightly technical question, but what's your zero-knowledge model then? Does the proof of security go through with concurrency, or is it just the cone of silence model, or?
It used a general zero-knowledge proof protocol. So essentially, the proof is based on the simulation. The adversary, so basically, we can simulate the transaction of the zero-knowledge proof, even though you don't know anything about it.
It's the traditional Goldwasser-Macaulay-Rackoff definition of zero-knowledge?
Yes.
Okay, thanks.
All right. All right. We're almost done. For the related work, redactable signatures has been studied quite well recently. There are several solutions both on Merkle hash trees and the aggregate signatures. Verification of outsourced databases are extensively studied recently. And for non-aggregate queries, a lot of studies is based on contexts where the user will obtain the clear text document. There's also a very large number of work on aggregate queries on encrypted data. And for those models, the data owner will encrypt the data using its own key. And actually, the user will, the data that the service provider hosts can only be queried by the data owner itself. So our model is slightly is different from theirs. We allow anyone to query the outsourced data. And also there's a lot of work on data generalization using methods to hide parts of the data so that the user's privacy is protected. So for conclusion, we have a general model and several techniques to prove data integrity in this outsourced model. And these solutions have potential applications in third-party auditing services and proof of compliance. And in our technical reports, we give formal security definition and proof of security. And there are a couple of open problems, as I mentioned earlier. In response to the IU's question, the linkability is one thing that we want to solve. Essentially, when the users issue multiple queries and the same commitments are returned, the user will figure out something. So one solution is to think about re-randomize the commitments. But that will involve the data owner to re-sign the new commitments. So that's one thing that we want to solve in the future. And also, in general, we want to improve the efficiency because right now the verification is linear in the sum and the max verification. All right, so that's it. Any questions?
I have a question.
Yeah.
When the root hashes don't match, do the schemes generally provide a way to pinpoint where the root cause of it is, at which spot it is in the document?
No.
It just tells you yes or no.
Right. You cannot tell. There's no way of telling because root hash is the only hash value the user has. So it can be anywhere, right? Yeah. Yeah, it would be interesting to pinpoint the place that someone has tampered with. Yeah.